Hi there and welcome to Tech Life, a channel where I aim to review everything from selfie sticks to laptops to IDs for coding, video editing, software for producing thumbnails, essentially anything tech related. If you are new to the channel, please consider subscribing. If you have anything that you think I should review, please let me know in the comments and I'll do my best to review that product. In this video, we will be taking a look at classes in C#. So far, we have seen the program class that is created when we create a new project. We have been replacing this class with our own. In this video, we will create more classes. So what is a class? A class is the fundamental programming concept in C#, defining both representation and behavior in a single unit. A class is a data structure that combines data storage with methods for manipulating that data. Classes provide the primary mechanism we use to create user-defined types. Classes are simply another data type that becomes available to us in the same way these predefined types are available to us. Classes are reference types that implicitly derive from the object class. To define a class, we use a keyword class. The class shown here is called shopping cart. Its instance variables are the data that it stores. So this data is things that it knows. The methods shown here are things that this class is able to do. So it can add to the cart, we can remove from the cart, or we can do a checkout. When we're designing classes, we should think about the following things. We should think about objects that we can create from the potential class that we're going to create. We should also think about what the class knows, so what data we're going to store in that class. And then lastly, we should think about what the class potentially can do, and those are the methods. And classes, like so many other things in programming, are hierarchical. So I just wanted to quickly show you this diagram. The diagram shows a class called animal, and obviously in the real world you probably wouldn't have a class called animal, but for this example it works quite well. So you've got a class called animal, and that animal class has a data associated to it in the form of instance variables and also behavior in the form of methods. We could potentially subclass this class and create different classes. For instance, you could have a subclass called lion, and when we do subclass a class, then these instance variables and the methods, they get inherited by all of these. So if you had a lion subclass, all of this data and the behavior would be inherited by this subclass. Likewise, if you had a subclass for dog, the instance variables and the methods would be inherited by this subclass. And the benefit of that is you don't have to recode all of this stuff. You can simply just create a subclass and start using these methods and these instance variables. Another great benefit of subclassing is that you can, even though you inherit these properties, you can override them, you can change them. So the make noise method, for instance, for lion would be somewhat more different than the make noise method for a dog. So obviously a dog barks and the lion roars, and again, you know, the wolf, I don't know what the wolf does, but whatever it does, it's probably slightly different than what a dog or a lion would do. So even though all of these subclasses would inherit all of these methods, we can still change the methods, override the methods, and make them more specific to our need. So obviously the lion make noise would probably be a roar, and the dog would be a bark, and a cat would be a meow. Inheritance is one of the 4 pillars of object-oriented programming, the other 3 being abstraction, polymorphism, and encapsulation. We'll probably have a look at 1 or 2 of those, but we probably won't cover things like polymorphism or abstraction. So I think it's time we should maybe fire up Visual Studio and create a couple of classes and put into practice some of the things that we've just been talking about. Okay, so again we're gonna create a console app. So we go to, you can either click here on create project, or we can go to file, new project, and we select console, and then we give this console app a name. I'm going to call it classes. Just keep it nice and simple. Do OK. This will create a skeleton console application. Okay, cool. So we're going to delete this programs.cs because we're going to create our own class. And then we're going to click on classes. So we're going to do a right click, we're going to do add, and then we're going to add a new item. And the item we're going to add is a class, and we're going to give this a name, and I'm going to call this car, because the class I'm going to create is going to be a car class. Okay, so I'm going to probably get rid of some of these because I'm not going to use them. Cool. So the namespace is classes, the class is car, and the first thing we're going to do here is we're going to declare some instance variables. So the 2 forward slashes means there's a comment. These instance variables are sometimes called fields. Sometimes called fields. Okay, the first one I'm going to create is going to be make. So this is potentially the make of a car. I'm going to declare this as private. It's going to be a string, so the type is string, and the name of the variable is make. And we're going to put a semicolon at the end of the line. I'm going to create a few of these, so I'll type these quickly. Again, I'm creating another one. Again, it's private, it's string, and this time it's called model. So potentially the make of a car could be a Lamborghini, but the model could be an Aventador. So that's where we're going with this. This one here again is private. Again it's a string, and this time it's a color. So the color of our car. We're going to have another private one, and in this one we're going to have declare this as a decimal, and this is going to be called engine size. So the size of the engine could be a decimal, so it could be 4.2 liters or 5.1 liter or 5.3 liters. So that's why we've got it declared as a decimal. Another private instant variable, and this one is going to be an integer, and I'm going to have this called top speed. I suppose it could be a decimal as well, but we're going to keep it simple. Top speed. The next one is a decimal, and this one is going to be called 0 to 60. So this is the 0 to 60 time. Typically it's going to be in seconds, unless it's a really slow Lamborghini. 0 to 60. And lastly, we're going to have another integer, and this is going to be called year. So this is like the year of the car. So 2023, 2022. So that's an integer. And next, we are gonna. So this is a potential data of the class. These are instant variables. So this is what the class knows. Next, we're gonna define what the class is able to do. So that we're gonna declare methods. Oops, I spelled this correctly. It doesn't matter obviously, but because it's a comment, but we still need to spell words correctly. So this is the behavior. And the behavior of our class. So potentially a car can start, and I'm going to keep this simple. So we're just going to have a console.write line saying the car has started, or the engine starts, something like this. Console.write start engine. Okay, so that's one method. Obviously, if we can start the engine, we should be able to stop the engine. So we might have another method saying stop. Again, it's just going to be a simple message to the console screen saying stop, right, parentheses, inverted commas, stop engine. Again, in real life, you wouldn't have a car method with, a car class with these methods, because they don't actually do anything. It's just for me being able to show you how to create a class, what to put into the class. So let's have another one, last method. We're going to call this what can we call this? I will call this accelerate. So a Lamborghini obviously needs to be able to accelerate. Accelerate. Console. .write. I hope I'm spelling that correctly. Accelerate. So these are methods. These are the behavior of the class. Things that the class can do. It can start the engine, it can stop the engine, it can accelerate. Okay, I think we've messed out the accessor here, so I'm going to make these public. Otherwise we won't be able to see them. That one's public. 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 Cool. those are our three methods. Okay, these variables have been declared as private, and they've been declared as private on purpose. When we declare variables or methods as private, then essentially that member or variable is hidden. These variables can only be accessed by other functions of the same class. No other class or function or object can access these, and we do this on purpose. We don't want just any old class or object being able to alter these values. The way we're going to alter these values is going to be by using something called properties. Come on, where's my cursor? So I'm going to push those methods down, and I'm going to place a comment here, and we're going to create some properties. These properties are sometimes known as getters and setters, getter methods and setter methods. So I'm just going to put properties, sometimes called getters and setters. This will be obvious to you in a second. Okay, so that's a comment. We know it's a comment because we've got 2 forward slashes. And the first property I'm going to create is going to be called make, and it's going to have an accessor of public. It's going to be of type string, because this make is of type string. This property is of type string as well, and I'm going to call this make. And we're going to have braces. Within these braces, I'm going to have get, 2 more braces, and I'm going to return make. Oops. Return make. So let's just summarize what we've done. This make property is associated with this make private string variable. It's good practice when you're creating these properties to name the property with the same name as the variable name, but start the property name with a capital. In this case, it's going to be a capital M for make, and this private string variable is with a lowercase. And what we're saying here is return the value of make. So when this property is called, the value that's contained within this make variable will be returned. In order to set the value of make, we use the keyword set, again with these braces, and we're going to say make equals value, and again this is going to have a semicolon like so. What we've said here is set the value of this make variable with whatever value is contained within this keyword value. The use of these properties provides encapsulation by allowing outside code to read and write these private fields rather than accessing these directly. So these fields are encapsulated, they're protected. The only way we can manipulate these is through these properties, and encapsulation is another one of the pillars of object-oriented programming. Okay, so we can continue with these. Let's create the next one, which is going to be model, so it's going to be public again. Model is a string, so that's going to be string. We're going to use a capital M for model, and then we're going to have the curly braces, and we're going to have the getter. Oops. We're going to have the getter to return small case model, because model is model with a small m, and we're going to have a semicolon there, and the setter is going to set the value of model, so we're going to say model equals value, and that's model. I'm not going to type all of these, I've actually got these pre-typed, so I'm just going to copy and paste the rest of these, but you can see what's happening. It's going to be exactly the same. So I created a property for each of the private variables that we've declared. Let's just clean this up slightly. And that's the getter there. That's its setter. Doesn't like these at the moment. Public decimal. And that's that one. Okay. So public is supposed to have a small p, and that's what happens when you copy and paste from Notepad. P int is small I, this closes this. We've still got some squigglies here because int is a small I. The rest of those look okay. Int year return has to be spelled correctly. Return the year and set the year. Excellent. That's good. Those are our properties. Cool. Okay, let's quickly build this. See if there's any errors. No warnings, no errors. A quick recap on what we did. We created the class called car. We declared some variables. We created 3 methods: start, stop, and accelerate. We created properties for all of our private variables. These properties provide controlled access to our variables, and they provide encapsulation for this class. In order to use this class, we're going to have to create another class. Okay, so we're going to create another class. We come up to our solution, our project, right click, add, new item, class, and we're going to give this class a name. I'm going to call this call this car test drive, I think. Car test drive. Okay, in this we're gonna have our main method. Oops. So I'm going to create a method called main, and it's going to be public static. Doesn't return anything, so it's void, and it's main. Within this main method, I'm going to instantiate our car class. So I'm gonna put a comment here. Create an instance. Create an instance of our car class. And the way we do that is we use the name of the class, which is car. We give the instance a name, so I'm going to call this on super. I'm going to call it supercar 1. So I might create another one. Equals, and we use the keyword called new, and then we use the name of the class again with parentheses and a semicolon. So this line creates an instance of the class that we created. The class that we created was called car. We used the new keyword to create a new instance of the car class. When we have an instance of the class, we can start using its members and its properties. Use the properties to set values. And in order to use the properties, we use the name of the instance. In this case, it's called supercar1. So if I type in supercar1 dot, and these are all the properties and methods that are available to us. And the first property I'm going to use is called make, and I'm going to set make to Lamborghini. Lamborghini. Okay, it doesn't like that because we have to use double quotes. Using single quotes means that we are declaring or defining a character. Okay, supercar 1.make equals Lamborghini. And we can continue setting the values to the rest of the properties. Model is going to equal. We're going to set this to Aventador. And I can set its color. And I'm going to set it to red. And we can continue setting these properties. Or I can copy and paste. Like so. Doesn't like year. Let's see why. maybe identifying here. Let's go back to our car class. We have got year as int. We didn't make it public, so it can't be seen. And let's go back. To our car test drive, and now we can see excellent, cool. So let's take a closer look at this. We're using the name of this instance to call the property.make. We know it's a property because it's got a capital M. If we go back to our car class, all the properties start with a capital. A string make with a capital M, and dot make with a capital M. So the make is Lamborghini, the model is Aventador, color is red, 0 to 60. I'm going to say 4. I'm not too sure what it is, but we'll see. Okay. Rebuild the solution, see if there's any errors. No errors, no warnings. So this is really important to note that we're not accessing the private variables. We're making use of the properties that we created. Okay, and let's make this do something. We're just going to push something out to the console. So I'm going to say use the property to actually get the values, and we're just going to output it to the console. So it's going to be console and dot write line, because we're going to probably display more than one. Hopefully they'll be on different lines. And then in order to display the values, again we use supercar1, and we will simply call make. I'm going to have a console.read line. Oh, sorry, read, not write. Read key. So this prevents the program from running quickly and then closing. Let's do a rebuild, see if there's any errors. No errors. F5 to run. Okay, so for supercar 1, the make is Lamborghini, and that's all it's done, is displayed. We set the value of make here using the property. So we were using the setter, and we used the value that was set here. Again, we use the property, and in this case the getter, the get part of the property would have been called in order to retrieve the value that is stored in the private variable make. So the actual value is stored here in the make variable. Excellent. Let's go back to car test drive. I'm going to copy this. Change is not allowed. Oh, still running. Okay. and instead of getting the make, I'm going to get the model. Again, capital M, because we're using a property model. Let's get a couple more. Top speed, top speed. F5 to build and run. Okay, so Lamborghini Aventador, 190 miles an hour. I don't know if that's correct or not, but it looks good. Okay, so that's one instance of the car class. We can create another instance if you wish. Let's create the second instance. So if I do and in order to create an instance, we know how to do that. So we use the name of the class, which is car. We give the instance a name, and I'm going to call it supercar 2 equals, I use a keyword called new, and then we use the name of the class again with parentheses and a semicolon. And now supercar 2 can make use of all the properties and methods that we created in the car class. So again, we can set the make, and let's have another one of my favorite cars, Aston Martin. Aston Martin and supercar 2.model can be the DB11. DB11, and I'm going to set the color. Color will be, let's go for silver. No, let's make it jet black. Jet black. By the way, guys, if enough of you subscribe and watch my videos, Tech Life might be able to afford one of these wonderful cars. Okay, so what have we done here? We've created another instance of our class. We've used the properties of that class to set the values of the variables, and then just as we did before, we can output display the values of the variables that we've just set, and we can do that. I'm changing this to 2 to 2. I'm going to move this down. I'll put it to here, and I'll put another console.write line here. Oops, wrong one. Console.write. Okay, all I've done there is I'm going to print out car class instance 1 and then the values of the variables of the first instance, and then car and class instance 2 and the values of those. And let's do a build. Looks good. F5 to run. Okay, car class instance 1, Lamborghini Aventador 190 top speed. Car class instance 2, Aston Martin DB11, and the top speed is 0 because we didn't set the top speed. Okay, let's go ahead and set the top speed, so we can't have it at 0. Copy that. Top speed, and that's an int, so top speed. Okay, let's do 185. F5 to build and run. And there we go. So one class, two separate instances. Each instance of the class has its own variables. Each variable can contain its own value. So even though we've got a variable called make in the class, because we have two separate instances of the class, each instance gets its own variable, and then you can set the values to each other variables. Cool. Okay, so we've seen how to use the properties. Let's have a quick look at how we use the methods of our class. If you recall, we have three methods: start, stop, and accelerate, and we can call those methods quite easily. And because we've already got a reference to an instance of our class, and we can use dot notation. So if I come down to clean this up slightly, that's using the properties, and that is the second instance. So for this instance, so we use a reference to the first instance, which is supercar 1 dot, and then if I come down here, I should be able to see all the properties and all the methods that our class has. We can see accelerate there. The one I want is start. Okay, so I've said okay, call the method start on this supercar 1 instance. If we build this now, rebuild, 0 errors, 0 warnings, F5 to run. Okay, so it's kind of written it to the same line as the, let me just correct that. We can see that it's actually said start engine, but because there was no right line, let's go back to our car class. Okay, we've just written on the same line, so I'm going to correct this slightly. I'm going to put these on separate lines. I need to learn to spell line. A line, okay. Rebuild. F5 to run. And so car class instance 1 is a Lamborghini for the make. The model is Aventador. Top speed is 190, and I've called the method, the start method, on this first instance. And our start method, all it does is print the words start engine. Okay, let's go ahead and look at another method, and in this case, we'll look at a method on our second instance. So if I come down to here, again, we have a reference to our instance, and that reference is supercar2 dot, and then I'm going to call the accelerate method. Okay, F5. And there we go. So for the Aventador, we've got a start engine, and for the DB11, we've got accelerate. So that was a call to the method. The start method comes into here, and all it does is print a message to the console. Likewise, for the accelerate method, it just says accelerate. Excellent. Okay, so I think I can wrap up classes there. Let's have a quick recap of what we did. The first thing we did was we created a class called car, and then we declared a number of different variables. We marked those as private. We marked them as privates because we didn't want anything outside of this class to be able to alter these variables. Then we went ahead and created three methods: start, stop, and accelerate. After that, we created properties. We created properties because we wanted to be able to manipulate these private variables by using these properties, thereby encapsulating the data and ensuring that only valid values of data can be passed into these private variables. After that, we created another class, and the reason we created this class was firstly so that it could contain the main method. Main method is where all C# programs start. So we created the main method in this class called car test drive. Within that main method, we created an instance of car. We created an instance of the car class. We gave that instance a reference. Using that reference, we could call the properties and methods within that instance. So we were able to set values using the properties, and we were also able to get the values that were set, again using the properties. Next, we created another instance of the same car class. So there's only one car class, but we can create numerous different instances of that class, and that's what we did. We used the new keyword to create the instance. We gave it a reference, supercar2, and using this reference we were able to manipulate and use the properties and methods within that instance as well. Cool. Hopefully you have found this short tutorial educational and helpful. If you have, please do hit the like button and maybe even consider subscribing so you don't miss the next part, which is going to be part 6. Thank you very much for watching. I'll hopefully see you in the next one.